that here. Okay, so we are good to start. Okay, so this is so we are still in the section 2.4, and again, it's about dividing polynomials. Right, and as I said, there's an exercise left from Monday. So I think we had like two problems. I think I solved the first one. So there's one left, which is, so I think we have to divide. So this is, we have to divide 4x4 minus x cubed minus x squared plus 2 by x minus 2. Okay, so yeah, so I'm gonna remind you how to divide, guys, right? So we said first, so I'm gonna divide this 4x4 etc. by x minus 2. So then it means that this is my dividend, right? And I'm gonna divide by x minus 2. So then my x minus 2, that will be my divisor, right? Okay, and then so so this divisor is supposed to be of the form x minus c, right? So then my c is of it's the opposite of, so it's minus 2. So it's supposed, c is the opposite, right? So then c is positive 2. So my c is positive 2, right? And it's the opposite here. It's supposed to be the opposite of this number here, right? Anyway, so we have the following table. We have like 3 rows. First row, first column, we need to put C in the first column, first row. So that will be positive, the positive 2. All right. And then next, first row, the next column, we're going to put the dividend. So here is my dividend. All right. So we start with the highest power of x, it's 4. So here's my x fourth, x cubed, then we have x squared, then x, and then constant. Okay, so again, guys, even though there's no x cubed, right, but you have to put 0 for x cubed, right? So so what I'm saying is so x power 4, the coefficient is 4. X cubed, there's no x cubed, but still we have to put 0 for x cubed. X squared, it's minus x squared, so it's -1. X, there's no x, so I have to put 0 for x. And then the constant, the number by itself, it's just positive 2, right? So that's my dividend, right? So again, don't skip, there's no x cubed, there's no x, so we have to put 0, right? Now, we said we're gonna bring down, you always bring down the first number here, right? Right, so I have 4, so I'm gonna bring down the 4. And then, so what we do, how did I get the -1? Yes, I did it, it's because, so you see this is negative x squared. So it's like, it's this, the minus means it's -1, right? This minus here, that's actually my -1. That's why I have my -1 here. Okay, it's because of the minus. All right. Okay, perfect. So we said next, guys, we have to multiply this last row by c, right? So multiply it by c. Right. So so then 4 times 2, that will be 8. So here's my 8, and then we're gonna add the numbers here. So 0 plus 8, that will be 8. Multiply by c, multiply by 2. 2 times 8, 16. So next column, I'm gonna put 16. Now I have -1 plus the 16. That's positive 15. So here is going to be positive 15, right? Multiply again by my c. The positive 2, 15 times 2 is 30. So here's my 30, right? And then I'm going to add, so 0 plus the 30 is equal to 30, right? And then again by 2, that's 60. So here's my 60. And then I'm going to have 2 plus the 60. So that would be my 62. So here it's going to be 62. All right. Now, how do we read the last row? So we said the last column, that would be our remainder. So this here, this is always the remainder, right? And then the quotient. So here's my quotient. So it's this thing here. That's my quotient. Okay. Now, how do we read the quotient? Well, we said here in the last row, though, here it will be 1 degree less. So I have here x power 4. So here it's going to be x cubed. It's 1 degree less, right? Here it's 1 degree less than the dividend, right? So if I have x fourth in the top, then here in the last row, I'm going to have x cubed. After x cubed, of course, there's x squared, there's an x, and then there is a constant. All right. So then my quotient, so the answer here, so my quotient would be 4x cubed plus 8 x squared plus 15x, and then the constant by itself, the number by itself, it's plus 30, right? That's plus 30, right? So that's my quotient. And of course, the remainder is 62. Okay. So is there any question, guys, about how I got this this answer here, or how I did this the table? Okay, no questions. Very good. So then, so then I have to remind you guys, you know, when you divide a number, when we divide, thank you, Leah. So when you divide a number, so you divide, so we have you have your dividend. That's supposed to be equal to the divisor, all right, times the quotient, right, plus, of course, the remainder, right? So this is plus the remainder here, all right? All right. Anyway, so like in this example, we have one more time, Samira, you mean the table? Okay, well, yeah, so that's probably because you missed the lecture on Monday, but so we are dividing polynomials. So here I have to divide this 4x fourth minus x squared plus 2 by this x minus 2, right? So what we have to do is in the first row, first we have to put this number c, and this number c is supposed to be the opposite of, so you divide by, so I have to divide by x minus 2, right? So I have to take the opposite of negative 2, which is positive 2, right? So that's why I put the positive 2 here, right here. And then still in the first row, next column, I put the dividend, right? I have 4x fourth minus x squared plus 2. So that's why I have this 4. You see this 4x fourth, 4x fourth. There's no x cubed, so that's why I have 0x cubed, and the minus x squared plus 0x, there's no x, and then the constant. And so what we do is you always bring down this number, first number here. I have 4. I have 4 here, so that's why I brought down this 4. And then the last row, what you do with the last row, you multiply by your C. I have C is positive 2, so I multiply it by the positive 2, and then you put the number in the next column. So for example, here, this is 4 times 2, right? 4 times 2, then it's 8, so I put 8 in the next column. And then what you do is you add the numbers here. So here I have 0 plus 8, so that's 8, right? Again, you multiply by this, by the C. 8 times 2 is 16, so I got here my next column, my 16, and you have to add it to the negative 1, right? I have negative 1 here, so negative 1 plus 16, that's why I got positive 15, etc. So you multiply by the C, the last row by the C, you put in the next column, and then you add the numbers in the column, right? And the last number here, I mean the number in the last row, last column, this one here, that's always the remainder, right? And then you have this, the rest here, that will be your quotient, and it's always 1 degree less than the dividend. Dividend is x fourth, the degree is 4. So here you start with power 3, right? It's always 1 degree less, right? Well, we're gonna do more examples, so don't worry. But anyway, so what I was saying is that our dividend is always equal to the divisor. Divisor times the quotient plus the remainder, right? So like here in this example, we have 4x squared, or 4x fourth, sorry. So it's so in our example, we have 4x power 4 minus x squared plus 0x plus 2. That's equal to our divisor. We divide by x minus 2 times the quotient. The quotient is this 4x cubed plus 8x squared plus 15x plus 30. Right, plus the 30. And then, of course, plus, and then plus the remainder. So plus the 62, plus the 62. All right. Now, guys, if you, so let me make the following observation. So let's say, so here's my dividend, right? Here, this is my dividend. This is my dividend, f of x. So let's say my f of x is 4x fourth minus x squared plus 2. All right. So what I'm going to do, I'm going to evaluate f of 2. Okay. So why do I want to evaluate this the f of 2? Well, 2 is that's equal to c, right? Remember 2? We said c is equal to positive 2, right? All right. So let's see what happens if you plug c in the function f. So this is my f of c. Right, my c is positive 2. So let's see what we get if you plug 2 in the function f. So that's 4 times 2 to the power 4 minus 2 squared plus 2, right? So that's, so then f of 2 is actually equal to, so 2 to the power 4, that's 16. 16 times 4, well, 16 times 4 is 64. Right? 64 minus, so this is 64 minus 4 plus 2, and that will be equal to 62. Now, does 62 remind you something? Well, 62 is exactly my remainder, right? This is exactly my, that's exactly my remainder. Yes, absolutely. So that's my remainder. Okay. And so, and actually this is like a general fact, because So this is actually a theorem which says that if you divide f of x by x minus c, right, then f of c would be equal to the remainder. Okay, so the theorem says the following. So if f of x is divided by x minus c, all right, then f of c is equal to the remainder. Okay. So why this is true? So what's the reason why f of c is equal to the remainder? Well, it's because okay, let me show you why this is true. Well, so remember, guys, I want to divide f of x, my dividend, by x minus c. So I have f of x equal to my divisor, x minus c, times the quotient, right? And plus, of course, plus the remainder, right? Now, what happens if you evaluate f of c? Well, let's plug c in the function f, right? So let's see what happens to f of c. Oops. So I'm going to plug c, right? So that's equal to, so I'm going to replace x by c, right? Substitute x by c. So this is c minus c times the quotient plus the remainder. Now, c minus c, guys. So again, I plug c in the function f. So I got c minus c. So c minus c is 0, right? It's just the same number. So this thing here is equal to 0, right? This is 0. Now, 0 times the quotient. So my f of c, that will be 0 times the quotient, right? Plus remainder. Now, 0 times the quotient, I mean 0 times wherever, is just 0, right? So this whole thing is just 0. This is just 0. This is 0, right? And so what's left? Well, just the remainder left, right? So then f of c is equal, so then f of c is equal to the remainder. And that's exactly our theorem, right? So you see, guys, why f of c is equal to the remainder? It's just because the way we write the, the division, right? I want to divide f of x, my dividend, by x minus c. That's my divisor. So I'm going to get some quotient, and there is a remainder left, right? So then if you plug c in the function f, you're going to have c minus c times wherever, right? That'll be 0. So the whole thing is going to be 0 except plus the remainder. So that's why f of c is the remainder. Is there any question, guys? You see why f of c is the remainder, right? All right. So then,
I have a question.
yeah,
So
please.
if we do the equation that you gave to evaluate, do we have, like, is there any purpose of doing the whole chart then if we're plugging in the c and then we're gonna get the remainder?
Well, the point is the quotient, right? We need the quotient too, right? So this, I mean, this tells you what's the remainder, right? F of c is going to be the remainder, right? But you don't know what's the quotient, and the quotient would be important for us later.
Okay.
Mm-hmm. All right. So then, well, what happens if the remainder is 0? All right. So let's see. Now the next question is, so what happens? So what happens if f of c, which is, we said is equal to the remainder, is equal to 0? So what happens if my remainder is 0? Well, okay, well then, you know, you're gonna have your f of x. Let's just write again our equation, right? F of x, our dividend, is equal to our divisor, x minus c, times the quotient plus the remainder, right? But we said the remainder is 0, right? This is remainder is 0, right? So here we're gonna have 0 plus 0, right? So then if your remainder is 0, or f of c is 0, then f of x is equal to x minus c times the quotient. And that's it, right? Times the quotient. Okay, and this is very good because if your function f is equal to x minus c times the quotient, it means that we got a factorization of f of x. So this is a factorization of f of x, right? Because you wrote f of x as a product of two factors. So this x minus c is going to be your first factor. So this is a factor, right? This is your first factor, right? X minus c is going to be your first factor. So we have a factorization of f of x. So this is a factorization of f of x. So what I'm saying, guys, is that, and this is also a theorem. So if your remainder or f of c is 0, then x minus c is actually a factor of f of x. So so this is another theorem. I mean, just consequence of what we just said. So theorem. So if f of c, which is the remainder, is 0, okay? And so when you say f of c is 0, it means that the c is a solution of f of x equal to 0, right? So if f of c, which is the remainder, is 0, then x minus c is a factor of f of x. Okay. So I mean, to make it simple, guys, let's say you divide. If you use numbers, let's say instead of polynomials, you divide 15 by 3, right? Let's say you divide 15 by 3. The remainder is 0, right? If you divide 15 by 3, you get 5, and the remainder is 0, right? So the remainder is 0. It means that 3 is a factor of 15. 3 is a factor of 15, right? I mean, 15 is 3 times 5. Right? So all I'm saying is that if the remainder, which is f of c, is 0, then the divisor, the 3 or the x minus c, is a factor. Then you're asking, let me see your question. Can you give us an example using information you said? Yes, yeah, of course. I'm going to give you a couple of examples. Yeah, sure, absolutely. But I hope you got the idea, guys. So what I'm saying is, if my remainder, which is f of c, is 0, then this x minus c is a factor, right? This is really important theorem. Actually, we're going to use it. So for example, right? Example. Examples. So first example, let me just start with a very simple example. So let's say f of x, suppose that f of x is divided by x minus 3, and we got, let's say, 25 as remainder. Right? So question is, what's f of 3? Okay. So see here, you see here, guys, I mean, I don't know exactly what's f of x. I don't know the exact expression of f of x. I mean, I don't know explicitly f of x, right? But I know that if I divide my polynomial f of x by x minus 3, I get 25 as a remainder, right? So then the question is, what's f of 3? Well, the 3 here, that's exactly my c, right? So the 3 c is equal to 3, right? That's here x minus 3. So if I take the opposite, of course, then c would be positive 3. So this is f of c, right? So, and we said f of c is supposed to be equal to the remainder, right? And so to answer the question, so then f of 3, so answer 25. Yeah, Leah, absolutely. So the answer is that f of 3 is 25. So you see, guys, even if I don't nothing about, I don't know the exact or the explicit expression of f of x, just because I know the remainder, right? I can evaluate this f of 3, right? Well, so this is just a very simple example. Now let's do one more example, another kind different example. So number 2. All right. So let's say you want to solve 3x cubed plus 7x squared minus 22x minus 8 equal to 0, given that negative 1/3 x equal to negative 1/3 is the solution. All right. So so let's take a look to this equation. So this is I have this equation, right? The x cubed, etc. So when you want to solve such equation, of course, well, you can think of the quadratic formula, but this is not, it's not a quadratic equation, right? Because the power is 3 here, the degree is 3, so we cannot use the quadratic equation, right? You can think of factoring, right? You can try to factor, but you can see here, I mean, there's no common factor, so you cannot really factor this. There's no common factor, right? You can think of partial factoring, right? But then if you do partial factoring, well, well, if you know, here, for example, you can say, well, I can pull out the x squared, but even if you pull out the x squared, you're gonna have like, you know, 3x plus 7. But here, this is on the last two terms here, this one and this one here, minus 22x minus 8, right? It's not the 3x plus 7, right? So I mean, even the partial factoring here, it doesn't work, right? So what I'm saying here is, factoring or partial factoring, okay, it doesn't work. It doesn't work here. All right. Okay, so I cannot use the quadratic formula. I cannot use partial factoring or just factor the equation. So what we're gonna do here? How do we solve this equation? Well, we have one piece of information here. We know that we have a negative 1/3. I know that negative 1/3 is a solution, right? So how can we use this this fact that x is that negative 1/3 is a solution? Well, so you know, so let's say my f of x. So I have my f of x, which is, you know, 3x cubed plus 7x squared minus negative 2x minus 8, right? So I know that because negative 1/3 is a solution of f of x is equal to 0, so I know that f of negative 1/3 is equal to 0, right? That's because yeah, so if you plug, yeah, if you plug negative 1/3 in the function f, you get 0. Yes, Glenn, yeah, absolutely. So yeah, so because, so this is because x equal to negative 1/3 is the solution of f of x equal to 0. Is the solution, right, of f of x equal to 0. So if you plug negative 1/3 in f of x, you get 0. Now, well, you know that f of negative 1/3 is equal to 0. So if I use the division, so this says that, so remember what we said here, guys. We said if, in the theorem, we said if f of c is equal to the remainder is equal to 0, then x minus c is a factor of f of x, right? So if f of negative 1/3 is 0, it means that x minus negative 1/3 is a factor, right? So if I use this theorem, then I know that x minus negative 1/3 is a factor of f of x. And because it's a factor, so you can write it like, you can write it like a product, right? Because it's a factor. You can write it like a product, and we know how to solve the product equal to 0. Either the first term is 0 or the second term is 0, right? So so what I'm saying is, because f of negative 1/3 is 0, then by our theorem, so by our theorem, x minus c, x minus negative 1/3 is a factor of f of x. And this is my x minus c. Okay? Again, because this is f of, so f of c, remember, f of c is equal to the remainder is equal to 0, then x minus the c is a factor of f of x. So how do we solve such a problem? Well, there are two steps. First, we're gonna divide. So step one, we're gonna divide f of x by the x minus c. Again, my c is the negative 1/3. That's my c, right? Right. And why I divide f of x by x minus c? Because I know x minus c is going to be a factor. And so I can write my f of x as a product, and then I can solve. So in the step 2, I can solve f of x equal to 0. Okay. Anyway, so let's follow these two steps. So first, I'm going to divide. So step 1.
Excuse me, Professor. In the step
Yes.
1, by f of x by x minus c of divide.
Yeah, so the x minus c is the x minus the negative 1/3, right? My c is, we said the c. You see here, here f of c is 0.
Yes.
So the negative 1/3. So here x minus c. What I mean by x minus c is x minus negative 1/3.
Yeah, I got that part, but
Uh-huh.
when you wrote divide by f of x by x minus.
Oh, sorry, divide f of x. Sorry. Yeah, here I meant divide f of x, of course.
Okay, that's
sorry.
clear.
Yeah, sure. Sorry, sorry. Yeah, and then sorry, and then solve, of course, f of x. Okay, so let's see. Let's divide f of x by x minus c. So so we're gonna divide. So what's f of x? F of x is the 3x squared x cubed, sorry, 3x cubed plus 7x squared minus 22x minus 8. I'm going to divide this by x minus our c, which is negative 1/3. So then, okay, so so here's my table. I'm going to have 3 rows. First row, first column, that's my c here. My c, we said, is negative 1/3. Then my dividend here. So that's my f of x, right? That's my f of x. That's my f of x. So we have start with x cubed, of course, then x squared, x, and then constant. So then we have 3x cubed, 7x squared, minus 22x, minus 8. Right? All right, so first step, we said to bring down this number here. Here's my 3. Now we multiply the last row by c. Multiply by c. So 3 times negative 1/3, that's negative 1. So here's my negative 1. Right? And then addition here, 7 plus negative 1, that will be positive 6. So here it's going to be positive 6. Positive 6 times negative 1/3, it's negative 2. So here is next column, I'm going to put negative 2. We're going to add, so this is negative 2, negative 22, plus the negative, this is a plus, of course, plus a negative 2, that's negative 24. So here's my negative 24. Negative 24 times negative 1/3, negative times negative is positive. 24 over 3, that's 8. So here's my 8, and then negative 8 plus 8 is, as expected, is 0. So here, if you don't get 0, guys, then it means that you made a mistake. Why? Because negative 1/3 is supposed to be a solution, right? F of so let me just remind you. So we said f of negative 1/3. This is supposed to be our remainder, and it's supposed to be equal to 0, right? That's because negative 1/3 is a solution of f of x equal to 0, right? So if you don't get 0, it means that you made a mistake somewhere. So this is, of course, our remainder. As expected, right? It's 0. Now, what about the quotient? And that's why here we're going to need the quotient, not just the remainder. So here's my quotient, and it's, of course, 1 degree less. So this is x squared, because here I have cube, then here it's a square, right? Then there's an x, and then there's a constant. So my quotient would be the 3x squared plus 6x minus 24. All right, and so what we are saying, guys, so this is why I divided by this x minus negative 1/3. So what we are saying is my f of x, my dividend, is equal to my divisor. I divided by x minus negative 1/3 times the quotient, so times the 3x squared plus 6x minus 24 plus the remainder, but the remainder is 0. So so this is, of course, this is my divisor, and this is my quotient. And so you see why we divided by x minus negative 1/3, because now in the second step, now I can solve, I want to solve f of x equal to 0, right? But because of I got this factorization, so I can use it to solve f of x equal to 0. So this is step 2. Now I can solve f of x equal to 0. But we just said that f of x is equal to this, right? This thing here. So my f of x is actually x minus negative 1/3 times the 3x squared plus 6x minus 24 equal to 0. And you see, because I got the factorization, it's a product. This is a product here. This is dot equals to 0. So when you have a product equal to 0, then either the first term is 0, or so either x minus negative 1/3 is 0, or 3x squared plus 6x minus 24 is 0. So you see, guys, why the fact that the remainder is 0 is important, because otherwise, if the remainder is not 0, let's say you have here, for some reason, you got +2, for example, as a remainder, right? And you want to solve this equal to 0. Then we cannot really solve it, right? Because we cannot really solve the equation, because it's not a product anymore, right? And even if you move this +2 to the other side, so you would say that will be equal to, that will be equal to -2. But if it's equal to some number, which a non-zero number, so if we have some, if it's equal to some non-zero number, then you cannot say anything about these two factors. You cannot say that one of them is 0 or one of them is -2. That's not true, right? So that's why we need 0 here on the right side. I need 0 here. Okay, so I need the product. I need the product which is equal to 0. Two numbers, product of two numbers is 0, then one of the numbers is 0. Does it make sense to you guys? You see why the remainder is 0 is really important here? Otherwise, I cannot really solve. Yeah. Yeah. Thank you, Glenn. Yeah. So then from the first equation, of course, as expected, I mean, that was given in the problem. So x minus negative 1/3 is 0, then x would be equal to negative 1/3. So that's, I knew this. We knew this solution, right? It's given it's given in the problem, right? Now, the new solutions, they're gonna be given by the second equation. So this one here. So then this is, of course, now we have a quadratic equation, right? So I can use my quadratic formula. So then my x, it's minus b, so it's -6, plus or minus square root of b squared, that's 6 squared, 36, minus 4 times a is 3, times c is -24, over 2 times 3. Right, so then x is -6, plus or minus square root of 36, plus, so minus, that would be a plus. So let's see, 24 times 3, that's 72. And 72 times 4, that's 288, right? Over 6. So then my x is -6, plus or minus square root of, so 288 plus 36, that would be 324, right? Over the whole thing over 6. Now, square root of 324, that's actually a perfect square. So that's plus or minus. Square root of 324 is actually 18. 18 times 18, that's 324, right? Over 6. And so then x is -6 plus 18 over 6. So that would be -6 plus 18, that's positive 12 over 6. That's equal to 2. All right. Or if you use a minus, so x -6 minus 18 over 6. -6 minus 18, that's -24 over 6. So that's negative, right? So it's -4. Right? I didn't do any mistake here, right? It's negative. Yes.
Question.
Yes.
Simplify 6, because we can simplify. It's a factor of 6.
No.
Here,
Oh
right?
yeah. You mean like in the top?
Yeah.
You factor out 6.
Yeah, to make it smaller numbers, because.
Yeah, you can say it's like a -1 plus 3.
Yeah.
Right.
Yes.
Yeah, you can do that too. Yeah, sure. However, one thing you cannot do it is to say, well, because I saw some people like here, they would say like here 6/6 cancel out, then the answer would be 18 or something, right? That's not true. So here they are like we are applying PEMDAS rule. So here you have first to do the top, or if you want to divide by 6, so we have to divide each one by 6, not just the 6, right? So anyway, so I hope you're so yeah. Anyway, so yeah, sure, you can do that too. Yeah. So this is 6 here, 6 here. So I'm gonna just put the 6 back here and 6 back here. All right. Yeah. So yeah, that's so I got my solutions, right? Here I got 2, and here I got -4. So now I find an answer. Find an answer. So solutions of. So you see, guys, how we use division to solve. To solve the equation. So solutions of this 3x cubed plus 7x squared minus 22x minus 8 equals 0, or so x equal to -1/3. That's given in the problem. And then I got 2 more solutions, 2 and of course -4. Of course, guys, here we were expecting 3 solutions, right? I have the highest power, the degree is 3, right? The degree is 3, so we were expecting 3 solutions, right? We were expecting 3 solutions, to have 3 solutions, right? 3 solutions. And actually we got 3 different solutions, all right? Any question, guys? So that's, yeah, so that's an example how to use our theorem, the fact that f of c is equal to the remainder is equal to 0, and that x minus c would be a factor. So here's an exercise, a similar exercise. So please try to follow the same steps, right? The exercise. So please solve x cubed minus 4x squared plus x plus 6 equal to 0. Given
Wait,
that
that was it for that one?
Yeah, I mean, we had just to solve. Yes. Remember, the question was, where is it? So the question was, yeah, here. Example number 2. We have to solve this equation, right? Given that -1/3 is a solution. So we said, first step, we divide. We had to divide by the x minus -1/3. And then second step, we have to solve f of x equal to 0. So I divided right here.
Yeah.
Here's my answer. I divided, and then I want to solve second step, solving f of x equal to 0. So I'm going to use the result I got from the division, right? So I got this. I got this when I divided, right? This thing here. So here's my f of x, and yeah. So yeah, I got my solutions, right? I got -1/3 and the 2 and the -4.
Okay.
Mm-hmm. So
Professor,
yeah.
this is kind of off topic, not off topic, but being that there's so many steps for one problem, it's like that
Yeah.
should be, we should have a bit more time to complete the test, because you'll give us a problem and it'll be 3 sets of these, you know what I mean? And they're so long.
Yeah. No, I decided, like, for the test, the next test, I'm gonna give you more time. Yeah, sure. Yeah, I understand that. Yeah.
Okay.
So here's a similar exercise. So we have to solve this equation here, given that, let's say, -1 is the solution. So given that x equal to -1 is a solution. Okay. So I'm going to give you, let's say, 10 minutes to solve this equation. So just follow the same steps, all right? So again, the steps are divide your f of x by x minus where is it? Yeah, well, x minus the c. The c is the solution, right? So here I said x negative 1/3 is the solution. So I had to divide by x minus negative 1/3, right? And then once you divide, you get your dividend equal to the divisor times the quotient. Then you can solve f of x equal to 0 using the factorization, right? Because again, x minus c, or x minus negative 1/3, is going to be a factor. So here, the same thing. So yeah, so please try to follow the same steps to solve this equation here. So what you really need to keep in mind, guys, I mean, what's really important here to know is that if you say, for example, in this exercise, you say -1 is a solution, so you need to know that x minus -1 is a factor of your function f, right? That's I would say, the point, or the main result here. All right, guys. I think some of you had trouble probably with division. I'm not sure.
Professor, I have a question.
Yeah, please.
If x is equal to -1, the opposite should be c equal to 1, +1, right? Well,
no. So the here when you say x is -1 is a solution, so your c is equal to -1. When you divide by, so if you divide by, let's say, if I say I have to divide by x, I have to divide by, let's say, x plus 4, then yes, then c would be the opposite. So that would be -4. But here we are talking about x being a solution, not dividing by x plus wherever, right? So when you say divide by x plus 4, then yes, then your c should be the opposite, so it should be -4. But here we're not talking about dividing by this -1. We are saying that -1 is a solution, so your c should be equal to the solutions, to the -1.
Okay, but in the previous example, it was x equal to -1/3. So
yes, so
x,
yeah, I'm gonna go, yeah. So you see here,
all right.
I said, so you see here, yeah, right here. I said f of -1/3 is 0, so f of c is 0, so my c is this -1/3. You see, so when I divide, so I divided by x minus the -3rd.
Then it would be +1.
That would be positive. Yeah.
And you take the opposite.
Yeah. So here I'm going to divide by x plus 1/3. All right. So yeah. So when you have a solution, then the solution is your c. So, but if you say I'm going to divide your function by x minus or x plus whatever, then yes, then your c would be the opposite of that number.
Only if we are dividing.
Yeah, when you divide, yes.
Only we are dividing by a positive number.
Yeah, yeah. Okay. All right, guys. So, yeah. So, yeah, as a solution, you don't need the opposite. An opposite. Yes, absolutely. Yeah, so absolutely, Kwame. That's my point. Yeah, that's what I'm saying. Yes, absolutely. So here, when you say x equal to -1 is a solution, so then, so by our theorem, x, our theorem, x minus the number given here, which is -1. So x minus -1 is a factor. Is a factor of f of x. So actually your c, you see here, so here x, this is x minus c. So your c is actually -1. So the c, our c is the solution, is the -1. Okay. However, so this step 1. So let's do the step 1. We have to divide, right? So we have to divide step 1. So we have to divide f of x by x minus the solution, or x minus c. So by x minus -1, which is of course x plus 1, right? Right, so my c, again, my c is just the solution. It's the -1. So here's my division table. So here's my c. C is, so -1. My f of x, so it's 1x cubed. So here's my x cubed, x squared, x constant. So 1x cubed minus 4x squared plus 1x. and then plus 6. Right? Now bring down this first number, which is 1. 1 times -1 is -1. -4 plus -1, -5. -5 times -1, +5. 1 plus 5 is 6. 6 times -1, it's -6, and 6 plus -6 is 0. So you see, I got 0 as a remainder. So this is, of course, my remainder, and that's what we expected, right? Because f of -1 is supposed to be equal to the remainder, it's supposed to be equal to 0. Supposed to be equal to 0, right? Because -1 is a solution, right? So f of -1 is 0. Yeah, so now I got my quotient. I'm gonna need my quotient. So this is my quotient, of course, and this is x cubed. So here we're gonna have x squared, then x, and then constant. All right, so I can write my f of x as divisor. I divided by x plus 1, or x minus -1. So x minus -1 times the quotient. So here's my quotient plus the remainder, right? Well, so then my f of x, it's x minus -1 times the quotient, which is 1x squared, -5x minus 5x, and constant is 6, so plus 6, and plus 0, the remainder is 0. So my f of x is actually x plus 1 times this x squared minus 5x plus 6. And this is plus 0. And that's perfect because it's, that's a factorization of f of x, right? So I wrote f of x as a product of two factors. So now I can solve my f of x. So that will be my step number 2. So now I'm going to solve f of x equal to 0, x plus 1, x squared minus 5x plus 6 equal to 0. So again, it's a product equal to 0. And again, I emphasize on the fact that you need a product and you need equal to 0. Okay, so to say that either the first factor is 0 or the second factor is 0. X plus 1 is 0, then x is -1, and that's that was expected, right? And or this one here, x squared minus 5x plus 6 is 0, and we know how to solve this. This is this quadratic equation. So then your x, so then x, it's minus b, so minus -5 plus or minus square root b squared 25 minus 4 times a times c over 2a, so 2 times 1, right? So then your x is +5 plus or minus, so 24 minus 20, 25 minus 24, that's 1, so square root of 1, so it's plus or minus 1 over 2, so x, it's 5 plus 2 over 2, that would be 3, 6 over 2, that's 3, or x, 5 minus 1 over 2, that's 4 over 2, and that would be 2. So I got 2 other solutions, 3 and +2. All right, so -1, 2, and +3. So those are my solutions. So the answer, final answer. So the solutions are, so x equal to -1, x equal to +3, and x equal to +2. So yeah, so is there any question, guys? So you see how it works. I mean, again, the starting point is we have this we have to solve this equation. Where is it? This one here, the x cubed minus 4x squared plus x plus 6 equals 0. Okay, so we cannot really factor, there's no common factor, so, or partial factoring. So, but the fact that that -1 is a solution, then you can say, well, then x minus the -1 would be a factor, and so I can write my f of x as a product, right, of two factors, and then I can use that to solve f of x equal to 0, right? Now the question you may ask, how can we solve, this equation here, if we didn't know that -1 is a solution, right? Suppose I tell you, well, solve this x cubed minus 4x squared, etc. equal to 0, okay? And that's it, without this extra information here that -1 is a solution, right? So that's what I'm gonna do in next section. So the next section, we're gonna see how to find the possible solutions of f of x equal to 0. So let me just finish. So we are done with this section. So I'm gonna just write down here a question. So how can we solve? So my question is the following. Question is, how can we solve this x cubed minus 4x squared plus x plus 6 equals 0 if we didn't know that -1 is a solution. All right. And well, then the answer is well, that will be the next section. Next section. So next section is the section, of course, 2.5. Okay, so we can move to the next section, right? So section 2.5, it's about zeros or solutions of zeros. So again, guys, when I say zeros, I mean solutions of f of x equal to 0, right? So zeros of polynomial functions. Right. So in this section, there is one main theorem we're gonna use actually to find solutions of f of x equal to 0. So the theorem is called the rational zero theorem. So theorem called the rational zero theorem. Right. So what does it say, this rational zero theorem? Well, you have a polynomial, so that f of x, I have x to the power n. There is the leading coefficient a subscript n plus etc. Then at the end, of course, you have a constant, a number by itself. Let's call it a subscript 0. Okay, so this f of x is a polynomial, be a polynomial. All right. So there's an extra requirement here, is that the coefficients a subscript I, right, are integers, okay, with integer coefficients. Okay, then well, so what does it say in the theorem? So what does it say in the theorem? Well, it says that then the possible, so this word here is really important when I say possible. So then the possible rational solutions, solutions or zeros of f of x equal to 0 are are given by factors of a subscript 0, the constant, over the factors of a the leading coefficient, the a subscript n. Okay. So what I'm saying here is that the possible solutions, rational solutions of my f of x equal to 0, so are given by the factors of the constant divided by the factors of the leading coefficient. And when I say possible, so when I say possible here, it means that the numbers, the factors of factors of constant over factors of the leading coefficient, they could be solutions. They could be solutions of f of x equal to 0, and they could be not solutions of f of x equal to 0, right? So they are just possible solutions. So for example, let's do an example. Example. All right, so let's say f of x is, let's say, 3x cubed plus 8x squared minus 15x plus 4. Okay, plus 4. Right, so well, so where is my constant, a subscript 0? The constant is just the number by itself. So that's my a subscript 0. That's my constant, right? That's the number by itself. That's my constant. Now, what's my leading coefficient? Leading coefficient, that's the number in front of the highest power of x, right? So here, the highest power of x, of course, is 3. So my leading coefficient would be just this is here my leading coefficient. So my a subscript n, my leading coefficient. All right. So now, what does it say? The theorem says that the list of possible rational solutions of f of x. So the theorem says, so the list of possible rational. So when I say rational, it means fraction, right? Rational, it's a fraction or quotient, right? Rational solutions of f of x equal to 0, of f of x equal to 0 is given by, so factors of the constant, or factors of a0, so factors of 4 here, right, over the factors of the leading coefficient. So here's my leading coefficients. So it's phi, right? So it's factors of phi. So what would be this list? So that would be, so the list possible solutions. So the list of possible solution, rational solutions. So it's gonna be, so factors of 4. So what are the factors of 4? So well, 4 is divisible by 1. So I'm gonna put plus or minus 1, right? So in the factors, guys, you have to use both plus and minus, right? So plus or minus 1. 4 is also divisible by 2. 4 over 2 is 2. So I'm gonna put plus or minus 2 because 4 is divisible by 2. Is 4 divisible by 3? No, right? 4 is not divisible by 3 because when you divide 4 by 3, there is 1 left, right? So 4 is not divisible by 3. So it's not a factor. 3 is not a factor of 4. Now, 4, is it divisible by itself? Of course, any number is divisible by itself, right? So plus or minus 4. So those are the factors of 4. Of course, 5 is not a factor of 4 because, I mean, any large number of, any number larger than 4 is not a factor of 4, right? So those are the factors of 4. Now, what about the factors of 3? Well, 3 is divisible by 1. 3 is it divisible by 2? Nope, because when you divide 3 by 2, you get 1. 1 is left, right? And then, of course, 3 divisible by itself. Okay. So now, to get the list of possible solutions, so what we do, we have to divide each of the factors. So each of the factors at the top by the factors of the bottom here. So you divide 1 by 1, and then you divide 1 by 3. And then you do the same for 2. So you take the 2, you divide it by 1, and then you divide it by 3. Same for 4. Take 4, you divide it by 1, and then you divide it by 3. So the list, so the answer here, so the list of possible solutions, rational solutions, list of possible rational solutions of f of x equal to 0 is, so the list is going to be, so first we divide 1 by 1. So 1 divided by 1 is 1. 1 divided by 3, so it's 1/3. Next, 2. 2 divided by 1, so it's 2. 2 divided by 3, it's 2/3. 4 divided by 1, plus or minus 4. And 4 divided by 3, 4/3. Okay. So all I'm saying, guys, is that, so these numbers here, so you see these numbers, this list here of numbers. So these numbers are actually possible. They are possible solutions of f of x equal to 0. So some of them are solutions of f of x equal to 0, and some of them they are not, right? So for example, let's check if, so what will be the first number here? First number, that's positive 1, right? So so let's check, for example, if, so let's check if, so let's check the list. So for example, we can check if x equal to positive 1 is a solution. So let's see. So to check if it's a solution of f of x is equal to 0, so you have to plug in, you have to plug 1 in the function f, right? So you have to evaluate f of 1, positive 1. So what's f of positive 1? Where's my f? Yeah, so it's 3x cubed. So 3 times 1 cube, right? So plus 8 times 1 square, minus 15 times 1, plus 4. So then f of 1 would be 3 plus 8 minus 15 plus 4. 3 plus 8, that's 11, minus 15, it's negative 4, plus 4 is 0. So if you get 0, then 1 is the solution, right, of f of x equal to 0. So, so 1, positive 1 is a solution. Okay, of f of x equal to 0. Now, if you try negative 1, so let's see. Well, they cannot be all of the, you know, some of them are solutions, some of them are not. But I mean, here we have our equation was, you know, the 3x cubed, right? So then the highest power is 3, so we expect to have only 3 solutions anyway. So so all of them, they cannot be solutions of f of x equal to 0 anyway, right? So you can check, for example, negative 1. So let's see if negative 1 is a solution. So let's see, check if x equal negative 1 is a solution. So then f of -1, 3 times -1 cubed plus 8 times -1 squared minus 15 times -1 plus 4. So then f of -1, -1 cubed, that's negative, so -3. -1 squared, that's positive, so plus 8. Minus 15 times -1, that's plus 15, plus 4. So then -3 plus 8, that's positive 5, 20, 24. So we get 24. And of course, it's not 0. So 24, it's not 0. So -1 is not a solution, right? So this is not 0. So x equal to -1 is not a solution of f of x equal to 0. So you see, guys, as I said, some of them are solutions, some of them are not. And anyway, it's x cubed, in the equation of that degree. The degree of the f is 3, so we expect 3 solutions anyway. So not all of them can be solutions of f of x equal to 0. All right, so here's an exercise, guys. Is there any question about this theorem? So you see how I got this list of possible rational solutions?
So we have to check every single number.
No. So I'm going to show you later how to find all the solutions. Because I mean, like here in this list, you have like, how many? Let's see, 6, 12. Like in this list, like you have 12 numbers, right? And if you're going to try all of them, well, of course you can try all of them, but in the test, you won't have time to try all of them. So I'm going to show you later how to use this list to find all the solutions, right? But for the moment, so you know how to find this list of possible rational solutions, right? So here's an exercise.
Go back and give
yes.
us a minute.
Excuse me?
Can you go back, go to the end and give us a minute to copy? Oh, no, to the end.
To the end, sorry.
Yeah, I just want to copy the last.
Sorry. Sure, no problem. Okay, so here's an exercise, guys. Exercise. And then, of course, then later I'm going to show you, as I said, I'm going to show you how to use this theorem to find all the solutions of f of x equal to 0, sorry. So let f of x be, so let's say f of x equal to, let's see. Yeah, so let's say it's 8 x fourth minus 3x cubed plus x minus 6. Okay, that's my f of x. So please find all possible rational solutions or zeros, solutions of f of x equal to 0.
Sir, question.
Yes.
For the -6, would the minus affect other factors, or you're only picking out 6?
I mean, if no, I mean the constant here is the -6. But anyway, for the factors, when you when I find the factors, so you're gonna always use the plus or minus anyway. It doesn't matter if you have minus or plus there, right? I mean, in the list, it's gonna be always plus or minus. Okay. Okay. So guys, you have let's say 5 minutes to find this list of possible rational solutions of f of x equal to 0. Yes, Samira, it's a long list, so that's why you know, if you want to find the solutions of f of x equal to 0, and and you try to check all the solutions, then I mean, in most cases that would take a lot of time, right? Because the list cannot be long. So that's why I will show you how to use the list without trying all the numbers in the list to solve the equation, right? But actually, the idea is just to, if you find one solution, right? If you find one solution, then you are good to go. Remember in the exercise we had in the previous section, if you know one solution, then you can divide and you can find the other solutions, right? So actually, the idea is just to find one solution. Once you find one solution, then you can divide and then you can solve the equation without trying all the numbers in the list. Because sometimes, as you said, the list can be very long. Just to remind you guys, so I will post the homework number 6 tomorrow on Blackboard. All right. We don't have much time. Like we probably have like 6 minutes. I don't know if you're done, guys. Anyone has trouble with the list?
I have a question. If you
Yes,
have
please.
a repeat list, you should repeat it or just leave one solution?
No, don't repeat don't repeat the numbers. If you already have the number in the list, don't repeat it.
Okay.
Mm-hmm. All right, guys. Well, anyway, we don't have much time. I mean, time really goes fast. So, yeah. All right. So let's do this. So as I said, so the list. Let me check. Yes, correct. Yeah, absolutely, Samira. Yes, it's correct. Yes, very good. So, yeah. So, well, your constant. So the list. So possible rational solutions of f of x equal to 0 or rational zeros is given by factors of the constant. So factors of my constant here, which is -6. So here should be factors of -6, okay, over the factors of the leading coefficient, the coefficient of the highest power of x. Highest power of x is 4, so my leading coefficient is 8, right? So here should be factors of 8, positive 8, right? And so yeah, so then the list would be factors of -6 So that will be, so 6 is divisible by 1. So we're going to have plus or minus 1. 6 divisible by 2, by 3. 6 over 3 is 2, of course. 6 is not divisible by 4, not divisible by 5, but of course divisible by itself, over factors of 8. 1, 2, 8 is not divisible by 3, but it's divisible by 4. It's not divisible by 5, neither by 6, and neither by 7, but of course it's also divisible by itself, right? So then you have to divide each of the factors in the top by each of the factors in the bottom. So, so then the list is going to be, so you take 1 here and you have to divide it by, remember guys, this is very important. So you have to divide by each of the factors in the bottom here. So it's 1 by 1, by 2, that will be half, by 4, 1/4, by 8, 1/8, right? And then next we have 2. So 2 by 1, 2 by 1, positive, or it's 2, plus or minus 2. 2 by 2, it's 1, but it's already in the list, so you don't have to repeat it again, right? Next, 2 by 4, you reduce a fraction, that's 1/2. We already have 1/2. 2 by 8, reduce the fraction, it's 1/4. We already have 1/4, right? Next, 3 by 1, that's plus or minus 3. 3 by 2, 3 halves. 3 by 4, so 3/4, and 3/8, right? Next, 6 by 1, by 2, it's 3. We already have 3 in the list. By 4, 6/4, reduce a fraction, it's 3/2. I already have the 3/2 in the list. And then 6/8, reduce a fraction, that's 3/4, and we already have 3/4 in the list. So that would be, so that's my list, right? So yeah, so don't repeat the numbers in the list, right? Yeah, so that would be the answer, right? That's my answer. All right, guys. Is there any question? So yeah, so next time we'll see how to use this. So next time, use the theorem to solve f of x equal to 0. All right. So I'm gonna stop here, guys, and I will see you, I guess, next Monday. Right. Thank you, everyone. And I will post the homework number 6 tomorrow on Blackboard as usual. Thank you, everyone. Take care.
Okay, bye, Professor.
Bye. Thank you. Appreciate it. Thank you, guys. See you on Monday. Take care.
Have a great weekend, Professor.
You too. Thank you. Thank you, Alexander.